In this lecture video, we're going to talk about section 8.3, which is the law of cosines. In the previous section, we used the law of sines to solve side angle, 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 side angle, and side sine angle cases of oblique triangles. That leaves us with three more cases. But angle, angle, angle can never define a unique triangle. So that just leaves us with side, angle, side, and side, side, side. Now, why can angle, angle, angle never define a unique triangle? Suppose that you had some triangle, and let's say that this one here, is 40 degrees. This one up here is 60 degrees. And then that would have to make this one down here 80 degrees. Whatever these angles are, it doesn't really matter as long as they add up to 180 degrees. But what all that this is saying is how far apart these sides need to be. You can have a really, really small triangle, or you can have a very, very, very large triangle with these exact same angles. 60 degrees, 40 degrees, and 80 degrees. So, since we don't know the length of any one of the sides, the only thing that we know are the degrees in between the sides, we can scale these triangles to be really, really small, really, really large, or anything in between. So therefore, we will never have a unique triangle. So therefore, the only ones that we still need to take a look at are side, angle, side, and side, side, side. Both of these cases need the law of cosines to start the solving process. So we need to start with the law of cosines. Since there is no angle opposite a known side, which is one of our requirements for the law of sines. So let's take a look at what the law of cosines is. If A, B, and C are measures of the angles of any triangle, and if A, B, and C are the lengths of the sides opposite to the corresponding angles, so again, this is a little bit hard to see on the printout that I have, but we have this right here. So we basically have the same setup that we've been working with. Then A squared is equal to B squared plus C squared minus 2BC cosine of A. Or equivalently, we can also rearrange the symbols to have this, the A, B, and C symbols to have this. It says you need to be familiar with the structure of these formulas. In particular, note that the letter that appears as the subject of the formula, so here A, here B, and here C, also appears as the angle, here A, here B, and here C. So while these might look like three separate formulas, the layout is always the same. Here you have B and C. Here you have A and C, right? So you have A squared plus C squared minus 2 times A times C. Here you have A squared plus B squared minus 2AB. So here we're never using the third symbol C. Here we're never using the third symbol B, and here we're never using the third symbol, which is A. But whatever we have on the left-hand side of the equation right here is also going to be the angle that we're looking for whenever we have the cosine at the end. And since we're always using the cosine, that's why it's called the law of cosines. All right, here it tells us, it says rule of thumb. I don't like the expression rule of thumb. Again, I didn't write these notes. So it's a good general rule. And if you're wondering why I don't like the expression rule of thumb, maybe you should look up the historical meaning behind the expression rule of thumb. I don't like it. But it is a good general rule to always find the largest angle or side when working with the law of cosines, and always find the smallest angle or side when working with the law of sines. That's just a general rule. It's not necessarily one that you need to follow strictly, and we'll probably even do an example here that we're not going to follow this, just to show you that it can still work nevertheless. Alright, so it says solve each of the following triangles. And again, whenever we're solving triangles, we need to find all angles and all sides. So here we know that this is side B, this is side C, so this is going to be side A since it's opposite angle A. So let's try to figure out A, what A is, and using the law of cosines, we see that A squared is equal to B squared plus C squared minus 2BC cosine of A. That's just the formula that we have up here above. We know that B is 5, so 5 squared. C is 11, so 11 squared. Minus 2 times 5 times 11 times the cosine of A, and A is 48 degrees. If we do all of this arithmetic, we'll find that A squared is equal to 72 points. It doesn't really tell us how many decimal places to take this down to, so I'll just do 4 for now. And therefore, if we're trying to find just A, then we need to take the square root of this, which comes out to approximately 8.50856. So now we know what A is equal to. Now that we know the length of a side opposite a known angle, now we can continue with the law of sines. So we'll have 8.50856 over the sine of 48, which is simply just A over sine of A. It's going to be equals to B over the sine of B, or 5 over the sine of B. If we try to solve for the sine of B, we'll have sine of B is equal to 5 times the sine of 48 degrees divided by 8.50856. Then B is going to be equals to the sine inverse of this, or simply equal to 25.89 degrees. And really, so far, the only new thing that we've done is applied this law of cosines formula. This portion right here is just the law of sines. But that was what we learned in the previous section. So now we found side A, we found angle B. Now all that we still need to do is find angle C. But since we already know two of these angles, we can say that C is equal to 180 degrees minus angle A minus angle B, which gives us that C is equal to 106.106 degrees. So now we know all three sides and all three angles. So we've solved this triangle. And this was using side, angle, side. Since we have here a side, an angle, and a side. Let's go on to the next one. Here we have a triangle G, H, and I. And we know the sides of this triangle, but we don't know any of the angles. So here we'll start off with not finding I, right? That's what the suggestion was, a general rule that we read earlier. Find the largest one. We're also not even going to start off with finding the smallest one either. Why don't we just find the one that's in between? Why don't we try to see about G? Just to show that it's just a general rule. But here, so we're going to have G squared then is H squared plus I squared minus 2 h times I times the cosine of g. And we know that g is equal to 13 squared, h is equal to 6 squared, and I 15 squared times 2 times 6 times 15 times the cosine of g. Which now, if we do this, we can if we solve for the cosine of g, and I will leave you this arithmetic to do, but this is going to come out to about 0.51 repeating, where the ones are repeating. So therefore, if we're trying to figure out what g is equal to b, this is going to come out to 59.26 degrees by simply just taking the inverse cosine of both sides. Alright, again, the only new step is to apply this formula whenever we have side, side, side. The arithmetic behind this stuff is definitely not something that's new, but now we know one of the angles, that's 59.26 degrees. Now let's go on to say h, and we're going to say that h squared is equal to g squared plus I squared minus 2 times g times I times the cosine of h, which is going to give us 6 squared is equal to 13 squared plus 15 squared minus 2 times 13 times 15 times the cosine of h. And now you can see that the cosine of h will come out to be 0.9179, meaning that h will be 23.37 degrees. So now we found both g and h. In order to find angle I, we can see that this is going to be 180 degrees minus g, which is 59.26 degrees, minus h, which is 23.37 degrees. So I is going to come out to 97.37 degrees. And here we have our three angles, so therefore we have solved this triangle. We zoom out since some of that got cut off earlier whenever I was calculating out angle I, but I think that we're all very comfortable with the fact now that the three angles within a triangle must add up to 180 degrees. Since we already knew two of them, G and H, we can take 180 degrees, subtract G and H in order to find the angle I. Alright, so I'm hoping that this law of cosines is going relatively easy for you, since all that we're doing so far is applying these formulas whenever we either have side angle side or side side side. Let's go on to number 3. And it says, a triangle playground has sides of length 575 feet, 595 feet, and 401 feet. So clearly we're dealing with side, side, side. What are the measures of the angles between the sides to the nearest tenth of the degree? So let's first draw ourselves a picture here. We have something that looks like this. Here is A, call this B, and this C. We'll say that this is 475 feet. Seems like a rather large playground. That's pretty awesome. We'll call this one right here 595 feet, and this one over here 401 feet, and we're trying to figure out these angles. So let's first try to figure out angle A. Now we will start off with the largest one, show you that it still works, that general rule works, even if we do that. And A squared is equal to B squared plus C squared minus 2BC cosine of A, which means that this is 595 squared is equal to 401 squared plus 475 squared minus 2 times 401 times 475 times the cosine of A. If you solve for the cosine of A, this comes out to about 0.085053, which means that A is equals to about 85.1 degrees by taking the inverse cosine of both sides. If we continue on now with finding B, we'll say that B squared is equal to A squared plus C squared minus 2 times AC cosine of B, which is going to give us 401 squared is equal to 595 squared plus 475 squared minus 2 times 595 times 475 cosine of B. So if we solve for the cosine of B, this will be 0.740998, which means that angle B is going to be approximately 42.2 degrees. Again, by taking the inverse cosine of both sides. Now that we know A and B, finding C should be relatively easy to do at this point, because C is just going to be equals to 180 degrees minus A, which is 85.1 degrees, minus B, which is 42.2 degrees. So therefore, we're going to say that C is equals to 52.7 degrees. Now, as you can see, as long as we know the formulas for the law of cosines and when to apply this, figuring out these angles is relatively straightforward as long as we do the arithmetic correctly. Since finding out that third angle, while we most certainly could have also done, in order to find C, we definitely could also do C squared is equal to A squared plus B squared minus 2AB cosine of C, and we could have done all of those steps as well. We would still end up with the exact same solution, but I think all of us will agree that this right here is much less arithmetic to do. Either way, the next page of the notes are now the practice problems, and as always, those are left for you to complete. So that concludes section 8.3, Law of Cosine.